Okay, today we're going to learn a cool trick. It's how to convert repeating decimals to fractions. We looked at some of the difficulties yesterday in doing so. How to, subtracting repeating decimals. You can't always do it, but I'm going to show you a cool little trick of subtracting repeating decimals that will allow you to convert them into your fractions. So watch this. This is a very cool technique. I have the instructions written for you. And then I have a lot of examples that we're going to work that are like your homework. Okay, so we're going to learn today. This over here is what we're going to learn. We're going to learn how to take numbers like this and convert them into fractions. Ones with repeating digits, because we know that repeating decimals can always be represented as fractions. We've been told that, and now we're going to see how we can prove that, or how we can convert any decimal that's repeating into a fraction. So remember in the last lesson, I told you we couldn't do, there's sometimes when you have these repeating fractions and you can't subtract them, like 4.6 repeating, you can't subtract 3.78 from it, right? Because where do you start? Do you start here? How far out do you go? 8 from 6, you got to borrow your number and get your 8, and then your 7 from your 5, but you haven't accounted for all these numbers, so it's kind of like you need to keep writing more numbers, and each time you write more numbers, you keep carrying this thing over, and you end up in this wonky situation, and you just can't do it. If any of you want to experiment with trying to subtract these two numbers, I feel free to go ahead and do so, but I think you're going to find out that it's very difficult to do. You don't know, where do you start? How far to the right do you start? However, let me ask you a different question. Let's go to a totally different question, or maybe a similar question, but can we subtract 0.3 repeating from 3.3 repeating? This is a little bit different of a problem than the one above. So in other words, can we take 3.3 and subtract 0.33333333? And the answer is yes. Yes, we can. Yes, we can. Because this 0.3 repeating and 0.3 repeating, this is the same thing. So if we subtract these two numbers, we just get 3. Let's try that again. So can you subtract 6.8 repeating, and can you subtract 2.8 repeating? And the answer is yes, because you can take 6.88888 minus 2.88888 and these are the same. These are the same. So you get 4. So 2.8 repeating, 6.8 repeating minus 2.8 repeating is 4. Similarly, we could take 0, well, how about 10.123 repeating, and we can subtract from that 5.123 repeating. And that would be like 10.123 minus 5.123 and these are the same. So your answer would be 5. So we're going to use this as a building block. This is one of our building blocks. Now let's take another building block, and then we're going to be off to the races. We're going to be off to the races and doing our homework. Okay, so here's the other building block. So if x is equal to 1.2345, what is 1,000 times x? Right? Well, 10 times x, 10 times 1.2345 is equal to just moving the decimal place. So it's equal to 12.345. And if you want to prove that, you can just take your 1.2345 and multiply it, let's multiply that by 10, and you get your 0, boom, then you get your 0, 1, 5, 4, 3, 2, 1. 5 decimal places, 1, 2, 3, 4, 5. And there we go, 12.345. And then similarly, 100 times 1.2345 is equal to 1.2345 is equal to 123.45. You just move the decimal 2. And 1,000 times 1.2345 is equal to moving the decimal 3 times. So you get 1,234.5. And this is all stuff, you know, we've done this before. We've done this before in other lessons, well before this one. So let's look, and now we have to extend it. Let's use our knowledge and extend that to this. How can we multiply 0.6 times, let's just multiply it not by 1,000, let's multiply it 10 times x. Let's just keep it a little bit simpler. So if x is equal to 0.666 ... If we multiplied it by 10, we're going to use the same principle. Over here, when we multiplied by 10, we just took our digit and we moved it 1 to the right, our decimal 1 to the right. So we're just going to take this decimal and move it 1 to the right, and we get 6.6666 ... or 6.6 bar. So 10x equals. We got to be really comfortable with doing these. Let's do a few more. So if x is equal to 1.8 bar, what is 10 times x? Well, we got to do our little expansion, 1.8888 ... That's our x. So 10 times x is just moving that decimal 1 to the right. So that's 18.888 ... which is equal to 18.8 bar. Let's do one more, and we're going to do this one times 100, just to make sure we really get it. So if x is equal to 0.12 bar, what is 100x? What's 100? 100 times 0.12. So let's say, well, x is 0.1212. So 100x, let's move that thing 2 to the right. And well, 100x is 12.1212 ... or 12.12 bar. Okay, so hopefully we got the swing of this. And this is our second building block. And now we're ready to go ahead and solve these equations. This is super powerful. Let's just, you know, we're done with this. Let's put down our happy cat here for our second building block. Because this is new. This is stuff you haven't done, multiplied repeating decimals by tens or hundreds. So now we're going to use our building blocks to convert 0.333 into a fraction. And we know what this is. Most of you know that the answer to this should be a third. Right? 0.3333 is a third. 0.66666 is 2/3. But let's prove that using the power of converting repeating decimals to fractions. This is awesome stuff. So we're going to let x be. So here's our strategy. We're always going to let x be our number. So we're going to say x equals 0.3 repeating. We're going to multiply x by 10, 100, 1,000, depending upon the number of repeating digits. Now, this is key. So if we have one repeating digit, we're going to multiply by 10. If we have two, we'll multiply by 100, 3, 1,000. So this, because we have one repeating digit, one repeating, that's the 3. We multiply by 10. So if x is equal to that, which is equal to 0.3333 ... then 10x is equal to, we're going to move the decimal 1 to the right, and so it's equal to 3.3333 ... So again, x is equal to 0.3, and 10x then is equal to 3.3 bar. Okay, now we're going to do our step 3. We're going to switch colors here. We'll switch it over to orange. And we're going to set up our 2 equations. The big one on top, 10x equals 3.3 bar. And on the bottom, we'll set up the small one. So x equals 0.3 bar. And now we're going to, in step 4, we're going to subtract them. So when we subtract, on the left, we get 10x. We can subtract equations. If this equals that and this equals that, then we can subtract these 2 things and these 2 things, and we can still have an equation. We learned that back in Unit 4, and I think earlier as well. So on the left, we get 9x. On the right, we get 3.3 repeating minus 0.3 repeating. These are the same. So on the left, or sorry, on the right, we get just a 3. Because this cancels. Now, how do we solve for x? Well, we're going to divide both sides by 9, back to our algebra, and we get x equals 3/9 equals 1/3. So x equals 1/3, and we proved that. Right? Just as we expected, we got the right answer. Worthy of a happy cat. Let's do some more tricky ones. Not that much trickier. They're just pretty much the same. Now, in this situation, I want to tell you I want you to point out we have 2 digits. So we multiply by 100. And in this case, over here, we have 3 digits. So we multiply by 1,000. Now, I want you, I suggest to you that this is homework help. I've given you kind of the clues, and I'd love it if you could just try and do both of these. And you're going to end up with a x equals something and 100x equals something. And over here, you're going to end up with x equals something, and you're going to end up with 1,000x equals something. And then when you subtract, you're going to get 999x equals something. And over here, you're going to get 99x equals something. So I'm just giving you kind of the heads up where you're going. It's a little help. Okay, so for those of you who've now wanted to do it, you have paused and tried, and now we are going to solve. Okay. So we have x is equal to 2.181818 ... So now the rule is, because we're multiplying by 100 because we have 2 repeating digits. 2 repeating digits, so we multiply by 100. So 100x is equal to 218.181818 ... So x is equal to, again, 2.18 repeating, and then 100x is equal to 218.18 repeating. Okay, now we're going to set up our 2 equations that we're going to subtract. So we say 100x equals 218.18 repeating, and x equals 2.18 repeating. When we subtract them, these are going to cancel. So we get 99x equals 216. So x equals 216 divided by 99. And that equals, after you do your long division, it's 2 and 18 over 99. And if we divide the top and bottom by 9, because they both are divisible by 9, we get 2 2/11. Very cool. And if you want, you can go ahead and go into a calculator, and we'll see how 2/11 is equal to 0.18 repeating. I'm going to go over to this calculator and just do that for you. 2 divided by 11 equals, see, 181818181818. All right, let's go ahead and do this one. Let's convert 0.12 repeating it into a fraction. So x is equal to 0.0120120012. And so 1,000x. Why did we use 1,000? Because we have 3 repeating digits. So 3 repeating digits, we need 1,000. So that equals 1, 2, 3. So the answer is 12.012 ... So now we're going to set up our subtraction and say 1,000x equals 12.012 repeating. And then x is equal to 0.1012 repeating. Now we get 999x equals 12. So x equals to 12 over 999. And both of these are actually divisible by 3 by our divisible by 3 rules, because 1 plus 2 is equal to 3, which is divisible by 3. And 999 is 27, which is divisible by 3. So those are both divisible by 3 and can be simplified to 4 over 333. And that is our answer. And we can come back over here to our calculator and check that out and go, well, 4 divided by 333 equals, there we go, 012, 012, and it goes on forever. All right, I think we have just one more problem, and this is going to be like a homework problem that you have. The homework problem that you have is going to be number, let me see. I'm taking a quick look over to which homework problem it is. It's going to be number 7, where we're going to try and show, in number 7 on the homework, you're going to show that 0.9 repeating equals 1 using this same strategy we've been using. But this one's going to do something a little bit different, but it's going to maybe open your eyes that you're going to see when you convert this to a fraction. It's going to kind of be something a little crazy. So I want you to pause and try. Now remember, here, how many repeating digits do we have? We only have 1. This isn't 2 repeating digits. It's only, well, we have 2 digits after the decimal, only 1's repeating. So we only have to multiply by 10. Okay. I want you to, this is homework help. I want you to pause and try. All right, now I assume you're done. So let's go ahead and do this. So x is equal to 0.49999. So 10x is equal to, we're going to move the decimal 1 over, and we get 4.9999 ... So that's equal to, again, 0.49 repeating, and this is equal to 4.9 repeating. All right, well, let's look at this for a second here. So we're going to set up our 10x is equal to 4.9 repeating, and we got to subtract from that 0.49 repeating. Well, we can't exactly do that because we actually have to create this extra decimal on this top one. So you're going to need to do this from time to time. So let's show how we do this. We just add that extra decimal. We go 4.99 repeating, And then we can subtract 0.49 repeating, because now we have decimals in the same line that repeat forever, right? Here we could not subtract 4.9 repeating from 0.49 repeating because our repeating nines are not in the same line. So to do that, we just write our 9 here repeating and then get rid of that one. Does that make sense? Hopefully that makes sense. So similarly, if you had 0.4 repeating and had to subtract from it 0.4 repeating, you had to subtract, you can't subtract these, so you'd simply convert this into 0.44 repeating and then subtract 0.4 repeating, and then you could subtract these two numbers because they're repeating decimals. Okay, so send me a note if that doesn't make sense. I can work more examples if necessary. Okay, so let's do this subtraction. So over here we have 9x, and that equals, well, these cancel, so we get 4.5. So 9x, well, let's keep it over here. 9x equals 4.5. Let's get rid of this guy. Let's multiply both sides by 2 to make this a little bit easier. Get rid of our decimal. So now we have 18x equals 9. Divide both sides by 18, and we get x equals 9/18, which is equal to a half. So x equals 1/2. So maybe some of you saw this in advance, but 0.4999 is, I mean, that's practically 0.5, right? On a number line, if this was, 0, 0.1, 0.2, 0.3, 0.4, and 0.5. This is 0.5 right here, but 0.499999999 is right bumped up against it. And because that 9 repeats forever, it ultimately becomes the same number as 0.5000. Because we just keep going with 999s, and it gets so close that it's the same number mathematically. This is crazy, but it's true. So you're going to see when you do your homework that converting 0.9 bar into a 1 is very easy if you understand this example and you understand this process. And this process is a happy cat because you have mastered converting repeating decimals to fractions. And we're going to sign off and say, we'll see you next time on lesson 11. I don't know what we're doing in lesson 11, but I'm sure it will be just as exciting and interesting. Take care. See you next time. Happy math. Happy cat.